Hey everybody, so today is going to be the first part in a multi-part video I make that goes over the MCAS problems that were released as part of a practice test. This was launched actually, these problems were available I want to say back in the fall of 2018 because the first administration of this digital next generation MCAS was in the spring of 2019. So I want to say this is that few years old here, but it's still up there on the website. This is the one the kids took the other day in school for the stress test for the infrastructure. But yeah, these are available online, and in the description of the video I'll have a link to the DSE website where you can take this digitally. So the purpose of this is to, one, give us some comfort in seeing that these are not scary and we can all do these and we can all do really well, and two, give us a point of reference. So all you students out there that in my class, you guys have a hard copy of this PDF. If you lost it, just ask. And this is the intention is for you to take notes as we do this, have something to go back to, and then when you're taking it online, you can go back to it and reference it, okay? Because there's a lot. There's this packet, which is the practice test, a preview test basically, and then the released items from the actual administration of it, which was in May of 2019, which you also have that packet as well, okay? So I don't know how many videos it's going to take because it takes a lot of time, and I don't want to speed through these, so yeah, we'll see how many I do in the time I have, and then I'll just keep working through it. So here we go. Let's read through each problem. The first problem. So we have Albert drew a line represented by this equation on a coordinate plane, and they give us a linear equation here. We have y equals negative 1/2 x plus 5. Then below it says, on the same coordinate plane, Penny drew a line that is perpendicular to Albert's line and passes through the point negative 4, 3. Which of the following equations represents Penny's line? So first of all, we read the problem through, okay? We look at our options, and we ask ourselves, what is the question asking us to find? It's asking us this. It's saying, which equation represents Penny's line? Okay. Well, this isn't Penny's line. This is Albert's line. They tell us this is Albert's line. They tell us Penny's line is perpendicular to it, okay? It's perpendicular to Albert's line, and it goes through this point. So there's a few different ways we can solve this, all right? There's a few things that we need to know about. One second. All right, so we have a few pieces of information here. We know that this is Albert's line. We know it's perpendicular to Penny's line. We're looking for Penny's line. It goes to this point. So there's a few things we can do here. We know we're going to end up with one of these four equations, right? And really the most important thing going into this problem is that do we know what perpendicular lines mean, right? Well, we know that a perpendicular line, right, has a relationship to the line is perpendicular to. So for example, this line has a rate of change of negative 1/2. We also need to know how to interpret a linear equation in slope-intercept form. So this is the m, right? Y equals mx plus b is slope-intercept form, and this equation's in that form. So our rate of change for Albert's line is negative 1/2. That means Penny's line will have a rate of change that is the opposite additive inverse of this. So sorry, the additive inverse of this that's also flipped, the inverse. So it's hard for me to say it. Let's say it's the opposite sign and flipped. Makes it simple. So the reciprocal but also opposite sign. So negative 1/2 would become positive 2/1. That's how you'd find the rate of change of a perpendicular line. So we know that Penny's line would have an m of positive 2/1. Okay, that we need to know. That immediately rules out these two, because we know that this has a rate of change of negative 2, as does this. Immediately crosses these two out, and now we know it's going to be one of these two. Okay. Now, from this point, what you could do is plug in these points to see if you get a true statement. So you can plug in negative 4 here, see if you get 3. Plug in negative 4 here, see if you get 3. Or you can plug in negative 4 and 3 and see if you get a true statement. That's one way you could do it, and I'll show you how to do that in a second. The other way you could use is point slope form. So let's do the point slope form first. So point slope form is y minus y1 equals m parentheses x minus x1. Okay, and we're going to plug these in. So we have our point here. We have our x1 or y1. So y minus y1, which is 3, equals m, which is 2, x minus x1, so x minus negative 4. Okay, so let's go ahead and get rid of that double negative. That becomes plus. So we have y minus 3 equals 2 parentheses x plus 4. Let's distribute that 2. Okay. So we're going to get y minus 3 equals 2 times x is 2x, 2 times 4 is 8. So now we're going to get y by itself, so we're going to add 3 to both sides. We're going to use the inverse operation, so instead of subtracting 3, we're going to add 3. Okay, so we're going to get y equals 2x plus 11. Now, that is going to be option B, right? We know that. However, let's say you don't remember how to do this. Let's say you take the test and you have no idea, you totally forgot the point slope form. It happens to some of us. It's okay, no judgment. It's not going to be in the reference guide, that formula anyway. So let's say you don't remember it. That's okay. You can just plug these right in. So let's say we cross these out knowing that the rate of change is going to be positive 2. Let's plug in one of the points. Let's plug in -4 and 3. So we're going to take the first one. So I'll use a different color here. So y equals 2x plus 5. And let's plug in -4 and 3. So our x is going to be -4, our y is going to be positive 3. So 3 equals 2 times -4 plus 5. So we just took these points and plugged it in. All right, so 3 equals 2 times -4 is -8. And -8 plus 5 is -3. So that is a false statement. Therefore, it's not the solution. Let's try the other equation. So we know this is going to be it, though, already, right? Because we kind of cheated. So we didn't cheat, we just did the other way. So y equals 2x plus 11. Let's go ahead and plug these in. So y is going to be 3, 2 times -4 plus 11. So 2 times -4 is -8. Yeah, so we have 3 equals -8 plus 11. -8 plus 11 is 3, so 3 equals 3. It's a true statement. So if you don't remember the point slope form, you can go ahead and just plug these two in, these points, and that'll work, right? That's really your best bet, okay? So hopefully that was helpful. Let's go ahead and try the next one. Okay, so let's check this one out. This looks really, really intimidating, and really comes down to just knowing or understanding how angles work. Okay, so there's a lot of information here. You don't really need all of it, but we're going to go through all of it. Okay, so they give us an example here. We have a triangle XYZ. Okay, and they tell us a compass and a straight edge were used to perform a construction given triangle XYZ. The diagram shows a completed construction. So you can see some markings here. You can see some arcs were drawn. Okay, let's go through this. I'm going to zoom out a little bit so you can see all of it. I just want to keep it large enough so you can read it. The following steps were used to complete the construction. An arc was drawn, okay, using the compass from point X, which is right here, from point X through the sides of YXZ, angle YXZ right here, to create point F and point E right here and here. Okay. So you can see how these points are drawn. Now you'll notice it says, this is where it's drawn. All right. 2 arcs are drawn with the same compass from point E. 2 arcs were drawn with the same compass setting, one from point F and one from point E. The arcs intersect to create point P. So first you start with the compass on a setting, you draw it, right? So these are going to be equidistant from here. We know that because it starts here. So right off the bat, we know that those are the same, they're congruent. Those two segments are congruent. That's important, okay? All right. And then from there, they then did it again. They took a compass setting, they kept it the same. They started at 1, they drew a circle, they did it here, and they cross at P, right? The arcs intersect to create point P. So let's think about that. They have a compass, they start at X, they keep it at one setting, they curl it, and it hits this line segment here at F, it hits this line segment here at E, and they mark that, okay? So that means obviously that these two distances are the same because the compass didn't change, right? So that these two segments are the same. Then they took the compass again, they set it to a distance, they started E, rotated it, started F, rotated it, and where those two arcs met is where they put P. That's where that is, okay? Okay. A ray was drawn with a straight edge from point X, right here, through point P. Okay, that's where this came from. The intersection of XP, which is this, right, ray XP, and line segment YZ, so we have to know our vocabulary here, we need to know our symbols, was labeled point G. So this is the ray, this is the line segment, part of the triangle, and then they intersect here. Okay. Based upon the construction, which of the following must be true? Okay. So only one of these things has to be true. Okay. And notice the wording must be true. So line segment XG, so let's look at that. That's what this is right here, is congruent to YG. Well, we just don't have enough information. We really don't know. We know that this little piece here is congruent to this piece. We don't really know anything about this whole length here or this length at all. We really don't know. So no, that's out. XG, line segment XG, which is right here again, is a median of triangle XYZ. Well, we're not sure. We're not sure. It could be a median. It might be a median, but there's not enough information here to tell us that. Okay. And in case anybody forgot, the median of a triangle is a line segment that connects one vertex to the midpoint of the opposite segment, right? So that would be stating if this is the median, that means these two would have to be congruent to each other, which we don't know. We're not sure about that. Okay. XG, right here, is an angle bisector of YXZ. Well, we're not quite sure about that. It sure looks like that because if you think about the equidistance here, so we know from here, from E to P, right, and from F to P, we know those are equidistant, right? We know these are the same distance because the compass set the same way. So that means this would be congruent to that. Okay, we know that. And notice here, this is a shared side. So we know that these two triangles are actually going to be congruent triangles because of side, side, side. Okay? So remember that. This is side, side, side triangles, therefore these two triangles are the same. Okay? And we'd have to understand that these would be the same distance because the compass isn't moving, right? And again, this is where the advantage of having scrap paper on the right is really helpful because you wouldn't be able to write this digitally in front of you, right? So this is looking pretty possible. And we'll go back to that in a second. XG is a perpendicular bisector of YZ. So XG is here. And it's saying it's perpendicular bisector to that. Well, we don't know. We don't know if it's a bisector. Maybe it's perpendicular, but we don't know if it's a bisector or not. So let's go back to this for a moment. So angle bisector of YXZ. So we're saying that this is going to cut this angle in half. That's an angle bisector. This problem requires you to understand a lot of vocabulary and notation, right? So we know that these two triangles are congruent. We know that because they share three congruent sides. Therefore, we know that corresponding parts of congruent triangles are also congruent. So this angle matches up with this angle. They are the same. There's the bell. So therefore, these two are congruent. If these two are congruent, that means this is an angle bisector. So yeah, that actually works. That totally works. All right. Yeah, that one. There's a lot going on, but it really just comes down to can you create two congruent triangles? You can do that, sure. And there's other ways to solve it too. That's the way I find to be the most helpful. All right, let's check this one out. Let's zoom out a little more here. Consider this polygon. What is the sum in degrees of the measures of the interior angles of the polygon? So they want to know sum. What's sum? Sum is when you add something up and you get the total, right? So we want to know the sum of the angles, right? And they tell us that this marking actually means that they're the same measure, but I don't think that really matters. It wants to know the total degrees. Okay, it's not asking us for the individual angle. All right, well, there's a formula you can use, and it's n minus 2 times 180, and n being the number of sides. Okay, so let's count the sides. 1, 2, 3, 4, 5, 6, 7. The 7 sides. So 7 minus 2 times 180, and then 7 minus 2 is 5. And you do 5 times 180. So we know 2 times 180 is 360. So 4 times 180 would be 720. 720 plus 180 would be 900. So it should be 900. Let's double check our math though. Let's just double check. So 5 times 180. Yep, sure enough, 900. So 900 degrees. So that's going to be our answer. But let's say you don't remember that. Let's say, I don't remember this formula. And there's a lot of people that won't remember this formula. That's okay. You can still do this. Check this out. Pick a vertex. So go here. And then start connecting it to the other vertices. Okay? Start doing that. There we go. Okay, so we have 1, 2, 3, 4, 5 triangles. What do we know about triangles? We know that they have a sum total of 180 degrees, right? Their interior degrees add up to 180. So let's say you forget this formula. It's okay. We're actually kind of graphically showing this formula right now. This is what this formula does. It just tells you how many triangles are in this polygon. So we have 1, 2, 3, 4, 5 triangles. You just multiply 180 by 5, and boom, there you go. So if you don't remember the formula, just draw the triangles. Boom. That's all you got to worry about. If it was asking you for the individual angles, like let's say they told you this was a regular polygon, which means all the sides and angles are congruent. All you'd have to do is divide your total by how many angles there are, how many arcs there are, right? Not arcs, sorry, how many vertices there are. So I believe there's 7, right? 1, 2, 3, 4, 5, 6. Yeah, so you just divide this by 7, and that would tell you what each individual angle is. Okay? All right. Let's see if we can do one more. We're almost at 15 minutes. I'm being rather long-winded. Okay, so this is a multi-part problem. I'm going to stop this video here and then do a new one with this one so it's not super long. It's a little broken up. So I'll see you guys in a second.